Swayam Prabha. Digital India. Educated India.
Good afternoon to one and all. Today I, Sanidhya Dikshit, and my friend
Anjanya Kaul
from Scottish International School are going to present a project on air conditioner and how its functioning relates to the second law of thermodynamics.
So let's start. Sanidhya, why are you looking so sad today?
That's because my AC has stopped working. I managed to narrow it down to one part, but I don't know why it's not working and what exactly this part is.
I think this is the cooling coil of the AC and I know how I can fix it.
How?
Because I know the physics behind it.
Really? Can you explain
Yes.
it to me?
Behind this is the second laws of thermodynamics. Let me explain it to you with a small video.
The second law of thermodynamics states that for a spontaneous process, entropy of the system increases. Look, I get that you're trying to explain to me the second law, but what exactly is a spontaneous process?
So, spontaneous process in simple terms means a sudden process. For example, whenever you flip the switch of your AC on, the energy in the form of electricity goes to the compressor, and that process is so fast that it happens even before a split second.
I see. So if that's a spontaneous process, then what is entropy?
Entropy, when defined in simple words, can be said as disorder plus transfer of heat.
I see.
Transfer of heat is when from a warmer region to a colder region the air blows, and this is the way of nature to attain equilibrium.
Okay.
And disorder in easy words means change. So, for example, when you flick the switch of the AC on, when the electricity transfers to the compressor, originally it is in the form of energy of electricity, but then it changes into heat.
How exactly does that explain disorder?
See, so the disorder is originally the warm air in the room goes into the ducts of the AC where the compressor is present. But then when the electricity which is there in the compressor, it turns a bit of the amount of energy into heat. It radiates heat, and the original temperature of the room, which is warm, adds more heat to it, which causes that change which is known as the disorder.
I see.
So
So that's why every time I try to drink coffee but it gets too hot and then I leave it for a few seconds, that's why it gets cold?
yes, whenever you drink coffee, especially in winters, you see there's some steam which is coming out of it, right? And then you ask your mother to cool it down. And all she does is wait for a few minutes, and then it is cooled. So why does this happen? This is all because of the transfer of heat. The heat from the cup, or specifically from the coffee, goes into the environment, which is known as the system in this case. And that is why your coffee gets colder, because the nature wants to balance the temperature of your coffee and the temperature which is there outside, the room temperature.
And that is what you defined as equilibrium.
Yes.
So it's basically like nature's way of saying, hey, let's even things out. In other words, what you're telling me is that heat transfer is nature's way of equalizing cold and warm regions.
Yes. For example, as we can see, one part of the room is warmer temperature as compared to the other part of the room. So, the warmer region transfers its heat or its air to the colder region to attain equilibrium. That means the warmer part, suppose, may be at 40 degrees Celsius and the cooler part at 20 degrees Celsius. So, to balance the things out, they both make the temperature equal, which is 30.
But doesn't this go against the law of conservation and mass and energy?
That's a very good question. But the AC does not go against the law of conservation of energy. And this is why. So, when you flick the switch of the AC on, the electricity, which is the form of energy there, goes to the compressor. I know that compressor does not use all of that energy, but some amount of energy is also released in the form of heat or radiation in this case. And that replaces the energy which is utilized by the compressor.
So basically what you're telling me is that the remaining part of the energy after the electricity is used by the compressor is radiated as heat. And that heat adds to the heat of the indoor air, which is pushed outwards by the AC, and that is the change in system which we are calling as disorder.
And because of the original electricity being less, but there is a heat radiation which is done, and that is why the law of conservation is still obeyed.
I see. How exactly does the compressor allow the AC's air to go outside?
So, as we know that heat or temperature is inversely proportional to the pressure, or in simple terms, when temperature is higher, the pressure goes lower. So, originally the pressure is very low because of the heat present inside. So, to convert it into high pressure, with a simple example, suppose I am using my fist to apply some thrust on a particular surface area. Right now, the thrust might not be enough to induce that much pressure. But what if I use my other fist to apply pressure on that? The thrust will increase, but the surface area is still the same. And that is why there is higher pressure, which will lead in the opening of the flap. And when the flap will open, the heat will be released in the outer part of the atmosphere.
I see. So I get the working of the AC, and I also understand the second law. How do both of these relate? And what can I do to understand the relation between them?
So, in the AC, here we have two components of it. The first component is the compressor and the air ducts. So, whenever we switch on the AC, the cooling coil does start to work. And that's when, because of the nature wanting to attain that equilibrium, the warm air which is present inside the room comes in from this duct and reaches the compressor. When it turns into high pressure, the flaps open, and then this is released into the outer atmosphere. Then the air from the outer atmosphere comes in through a duct and goes inside this cooling coil.
Because it wants to attain equilibrium as well.
Yes, and then the refrigerant inside this cools and condenses it so that it can be released inside the room and the temperature is regulated.
So, since we have understood all of the issue, how about we demonstrate it practically for one?
Sure. The refrigerant.
The refrigerant, yes, let's replace it. Alright, now that the refrigerant has been replaced, we will measure the temperature to see if it's working. Measure. Alright, I think that's enough of a demonstration to check how much it's getting. So, Anjana is getting the temperature of?
High. The temperature, as you can see, is coming out to be high. That means the heat flow is so much that the thermometer was not being able to calculate it.
On my side, the temperature is 94.3 degrees Fahrenheit, which is much lower than what would be shown on Anjana's side.
This proves that the laws of thermodynamics are being obeyed.
Thank you.